All right, my name is Mathias, aka of Lidinbrunn, and welcome to Cache Me If You Can. Today, we are going to talk about caching, more specifically something I call offline caching. And when I say offline caching in this talk, what I mean is features in web browsers that allows web servers to tell the browser to store this content in the browser so that if the user goes offline, they could still view that content. And if you simply want this kind of functionality in your application today, you'd probably or maybe go on Google and search for offline caching, and you'll find some Stack Overflow threads that says that, oh, you should use something called service workers. And service workers is something that was introduced just a few years ago, and it's basically a JavaScript file on your domain that can act as a proxy to create client-side dynamic cache, so that when the web browser makes a request, before it's actually sent to the server, it has to go through the service worker, so then the JavaScript in the service worker can decide if you should respond from the cache or if you should send the actual request and fetch it. And this is very handy because since this will always be called first and this service worker will be stored on the client in the browser, that means that even if you pull the plug or disconnect from the Wi-Fi, the service worker can still give you content. So the service worker can say like, oh, you seem to be offline, so then I'm going to serve this, hey, you can't use this app when you're offline page. Franz Rosen and I started digging into this in the beginning of this year, and we didn't really come to a lot of exciting findings about this, more than just saying that it seems like this has been implemented with security in mind, at least from what we could tell. For instance, these service worker JavaScripts, they have to be served with content type application JavaScript. You can't just use a text file, for example. And if you want to use the cache on the entire origin, the JavaScript file must be placed in the root of the origin. So in example.com/blah.js instead of /hello/blah.js. So, we thought shit happens, but when shit happens, you should keep digging until it unhappens. And we found that before service workers was a thing, there was actually a similar functionality. It worked in a completely different way, but it's called the application cache. And it has two features. It can tell the browser to cache specific content for online use, so that if you know like these files will always be static, you can force cache them in the web browser. And it also has a fallback functionality, so that if the web browser is offline, you can say, then you should always serve this file. And how you implement this technically is simply like this. On your HTML tag, you set a manifest attribute pointing to a file, and the syntax of application cache looks like this. It needs to start with cache manifest, and then you have the cache directive, which just says to the browser, hey, you should fetch these resources and store them in the offline cache. And then you have the fallback directive, which says that if the user is offline, then everything under slash in this example will serve sorry, you are offline.html. And last, it has the network part, which simply says these rules should apply to these protocols. So star will be HTTP, HTTPS, etc. But we found something very interesting about the fallback directive, which is this. It wasn't quite true that this was only used when the web browser was offline. It would also trigger when the web browser was online and the web server responded with an error code, like 404 or 403, etc. And because of that, we could draw this conclusion, which was, well, if we could upload an HTML file and a TXT file on a domain, then we could hijack all the 404 pages. But it's like, if I can upload an HTML file on your domain, then maybe you have worse problems than cache poisoning. So back to the drawing board. So we've tried to find different ways to apply this to application, and we found one pretty interesting way, because the way that a lot of modern services allow users to upload content is that instead of putting it on your web server, for instance, they'd use an external cloud service like Amazon S3, for example. And so that has some interesting parts. And so a common pattern that we saw, which was exploitable, and I will show you, was this. Us or someone as a user would upload a file to the server. The web server will put it in a cloud storage, such as S3, and then because the application doesn't want anyone to read these files, they will link to the files with something called a signed URL. And basically, what that means is that you have some secret key in the query parameter of the link. So for the Amazon S3 case, it would look like this: Amazon S3, Amazon AWS.com, then the bucket ID, and then the file path, and then question mark, and then the signature. If you would request this file with the signature, this PDF would download. Without the signature, you can't view it. So how do we combine these two to steal people's files? Well, since this is a shared service, S3, anyone can create an S3 bucket and upload stuff there. So what if we upload our cache manifest on S3 and say that, well, every file that gives a failing error code, or if the user is offline, you should actually serve our attack file in a completely different bucket for all networks. Well, that works, and that's nice, because then after they view this page, every 404 page on S3 will give us our file. But there's one problem with this, and it's that the good stuff will not actually return 404, because when they go to these signed URLs, it will return 200. So we thought maybe we could force Amazon to give failure codes on everything, even if the file actually exists and the signature is correct. And you can, because you can use something called a cookie bomb. And it's a pretty simple concept. Basically, you fill the cookie UR by a JavaScript like this. So in this JavaScript, I create 10,000 cookies and fill them all with 1,000 A's. And what happens after this is that because cookies are automatically added to subsequent requests to the origin that they are set on, every request after they view this will contain like a shitload of cookies. And a lot of servers don't like that, so they will say like, hey, request too large, or bad request, or you guessed it, an error code. So this is how it looks for Amazon S3. I don't know how well you can see, but the scroll bar over there is pretty small, so you can imagine it's pretty large. And the response looks like this. Perfect. That means HTML manifest on a shared storage service plus cookie bomb means that we can completely poison the domain and all the rest, or all the following requests will serve our file instead. And so if you have been with me, you could understand that the attack pattern to steal people's signed files would look like this. First, we cookie bomb them and put the HTML manifest so that S3 will always serve our file. And then when the user clicks the signed link, S3, or actually their poisoned cache, will serve our file instead. And from that file, we can read the signature from the URL, and then we have stolen the signature and we can download their private file. So yeah, if you're anything like me, okay, that looks like crap, but I have a demo. the demo gods are with me. Can you see this? Oh, shit. Okay. Can I do this? Yeah, there we go, kind of. So here we are on Amazon, and this is sect example bucket, and then I just made a fake signature. And example.txt, and then we go and visit this little fun URL. And then when we go back, it's not a TXT file anymore because it's my HTML file. And we can also see that no matter what we try to request here, it's our file that will be served. Yeah. So to end this, you might think like, well, if the browsers had security in mind and they implemented this directory-based control for the service workers, shouldn't they kind of backport that to app cache? And I think you're right if you think that. And that's in fact exactly what Chrome has done, Firefox has done, Safari will do, but haven't yet. And yeah, I know it's almost sarcastic, but Internet Explorer said that because app cache is deprecated, we will not consider it for a security release, but we are considering fixing it, fixing the issue in a future release. And what that means, I'll let you be the judge of that. So yeah, that's all I wanted to present today. Thank you very much.